Imagine a world where giants roamed the earth, a time when creatures were so powerful they could shake the very foundations of the planet. Welcome to the Age of Dinosaurs. Today we're exploring the most terrifying predators ever to walk the planet. From the mighty T-Rex to the horned Triceratops, get ready to be amazed and terrified. Let's start with the king of the dinosaurs, Tyrannosaurus Rex, king of the dinosaur age. Let's be real, who doesn't love a good old T-Rex, right? I mean, everyone's been obsessed with it for over a century now. But the truth is, our image of this dinosaur might be a tad outdated. Stick around because we're about to reveal the real T-Rex. And trust me, it's not what you've been picturing. Tyrannosaurus roamed the ancient landmass called Laurasia millions of years ago, starting in the Jurassic era around 66 million years ago. This was towards the end of the Cretaceous period, when they were the big, scary meat eaters, ruling the roost in places like North America, Europe, and Asia. The first T-Rex skeletons were discovered back in the early 1900s. But fast forward to the 70s when there was a dinosaur renaissance, and suddenly, T-Rex was seen with a horizontal spine, flat back, and tail in the air. Basically, not the Godzilla-style pose we all grew up with. But, and there's always a but, many paleo artists are still sketching T-Rex with the old-school upright posture. However, more than 100 years of digging up dino bones has taught us some pretty different things, including the fact that this gigantic creature could even swim. The first nearly complete skeleton of this amazing creature was discovered back in 1902 by a paleontologist named Barnum Brown in Hell Creek, Montana, USA. Brown and his gang were pretty hardcore. They used dynamite as their tool of choice to blast through the rocks around Big Dry Creek stream. And it was no walk in the park. Scorching temperatures hitting a crazy 43.3 degrees Celsius, 110 degrees Fahrenheit, and not a tent in sight to escape the blazing sun. But hey, hard work pays off, right? They hit the jackpot with not one, but 3 T-Rex individuals, including 2 almost complete skeletons. Now, one of these impressive finds is proudly on display at the American Museum of Natural History. Now, the name Tyrannosaurus Rex was coined by a guy named Osborne back in 1905. The name is a mashup of Greek and Latin, meaning tyrant lizard and king, respectively. So, it's basically the king of the tyrant lizards. Quite the title, honestly. T-Rex had some famous cousins too, like Albertosaurus and Giganotosaurus. Scientists have stumbled upon about 20 T-Rex skeletons, although most are partial. But there's this one gem named the dueling dinosaurs, an almost complete adolescent T-Rex tangled up with a Triceratops. If we look at the fossil records, these tyrannosaurs evolved over a whopping 100 million years. That's a long time. They had these unique features in their bones, especially their skull and pelvis, which make them easy to spot. Back when they first came into existence, they were small with long arms and just 3 fingers. But as time went on, the T-Rex got bigger and scarier. By the end of the Cretaceous, they were huge and looked almost the same as each other, like a big family of monsters. Their heads were massive, with this box-like shape and big eyes, giving them a keen sense of smell. Their necks were thick and strong, supporting their heavy heads, and boy, their jaws were like something out of a horror movie. They had these massive teeth, sharp like saws, that could crunch through pretty much anything. Plus, they'd leave these telltale marks on their prey's bones, like Triceratops. Their bodies were kind of short, and their arms were tiny with just 2 digits, but they had holes in their bones that helped keep them light despite their size. And even though their arms looked small, they were as long as a grown man's arm. For the longest time, scientists scratched their heads, wondering what on earth those little arms were good for. But in 2018, some paleontologists spilled the beans at a conference, suggesting those tiny arms were more flexible and useful than we gave them credit for. These researchers went all tech-savvy, using X-ray imagery and computer models to check out the joints of T-Rex's modern relatives, specifically turkeys and alligators. While their research hasn't hit the shelves yet, they threw out a tantalizing proposal. Those puny arms might have been handy for bringing prey in close for a bite. But before we start praising T-Rex as the ultimate predator, let's talk about speed. The long, sturdy leg bones of T-Rex have sparked debates. Some argued these dinos were pretty darn fast, capable of running like ostriches. However, here's the thing. The muscles and tendons responsible for running aren't preserved in the fossil record, so estimating T-Rex's speed has been like shooting in the dark. Scaling up from smaller animals doesn't cut it either, because big guys like T-Rex put way more strain on their bones and muscles. So, the mystery of T-Rex's running abilities remains, well, a bit of a mystery. However, scientists have thrown out a whole spectrum of top speeds, ranging from a modest 18 to a jaw-dropping 70 kilometers per hour. In 2017, a groundbreaking study took a fresh approach, blending biomechanical simulations with stress measurements on the dino skeleton. And guess what they found? If T-Rex even attempted a sprint, it would put too much strain on its leg bones, risking fractures. So, instead of a full-blown sprint, T-Rex was probably limited to a brisk walk or a birdie sort of jog, maxing out at around 30 kilometers per hour. Yep, that means an Olympic sprinter could easily outpace one. A little quick sidestep about the Tyrannosaurus ontogeny. There are no mid-sized predators. It just goes straight from dromaeosaurs like Dilophosaurus right up to Tyrannosaurus, which is weird until scientists worked out that Tyrannosaurus take almost as long to grow up as humans do, reaching adolescent size and then plateauing there for 10 years or so before turning into the huge, gnarled adults. So Tyrannosaurus was the mid-sized predator of the Hell Creek Formation. The younger individuals hunted smaller animals, and then they grew up and changed niches to hunt large Edmontosaurs and Triceratops, which is wild, but not for long. Tyrannosaurus Rex had an average lifespan of around 28 years. Back in the day, the landscape looked quite different from what we see now. The current dry and grassy areas were probably more of an open woodland and a Louisiana floodplain when the T-Rex was living. And coming to the weather, it was warmer back then, with lots of flowering plants blooming. T-Rex wasn't a loner either. In fact, it lived in a bustling community with all sorts of dinosaurs, mammals, and insects. Now for some size comparison. A T-Rex was about 40 feet long, roughly twice the length of a modern elephant, and standing tall at almost 12 feet, it was slightly taller than your average African bush elephant. But a Tyrannosaurus Rex weighed in at more than 8 tons, and that's double the weight of an elephant. There's also another thing recent fossils have helped discover. They show us that lots of dinosaurs, even T-Rex's cousins, had these soft, fluffy feathers. Back in 2004, they found Dilophosaurus, a little T-Rex relative, having some basic feathers. Then, in 2012, they uncovered Tyrannosaurus, which was a massive feathered dino, totally changing our ideas. We used to think only the little dinos needed feathers for warmth, but Tyrannosaurus flipped that script. Suddenly, we're thinking all tyrannosaurs, even big old T-Rex, might have been fluffy. But there is a twist here though, because in 2017, they checked out some fresh T-Rex skin fossils and found scales, no feathers. Now, paleontologists are deep into a debate about it. Maybe baby T-Rex were fluffy, who knows, but they most probably had more of a leathery, scaly look. Now here's one thing you should know about the T-Rex's tail. It was stiff and pointed, and it would wag from side to side when the big guy was on the run. Some scientists think it helped with balance. You see, the T-Rex had this massive head, and to stay agile and make quick turns, that tail must have played a crucial role in counterbalancing angular momentum. Now, let's talk about that impressive jaw. It measured a whopping 4 feet, or 1.2 meters long, and the lower jaw had some flexibility to it. T-Rex had 50 to 60 thick, conical, serrated teeth. They came in various sizes, with some as small as 3 to 6 inches, or 8 to 16 centimeters long, while others reached a staggering 13 inches, or 33 centimeters. And get this, T-Rex could actually grow its teeth back. It took about 2 years for a replacement tooth to grow inside the jaw, alongside the root of the current tooth. The front teeth were D-shaped and great for gripping prey. Scientists even suspected that T-Rex could crunch through bones, and they weren't wrong. Fossil discoveries of T-Rex poop showed bits of bones in there. When it comes to bite power, its powerful jaws and teeth could exert up to 6 tons of pressure. That's enough to crush a car in half with just one bite. It's pretty solid evidence that T-Rex was practically built for bone crunching. This ultimate carnivore could devour a staggering 500 pounds or 230 kilograms of meat and bones in a single bite. Now, let's crunch some numbers to see how much food a 6-ton T-Rex would need daily. To put it in perspective, an African bush elephant weighing between 2 to 7 tons munches on around 70,000 calories per day. Some estimates suggest T-Rex would require around 140 kilograms of meat daily. So, what was it eating? Well, it likely went after herds of horned and duck-billed dinosaurs. But it was also an opportunist, munching on anything from carcasses to unfortunate T-Rexes. Now, when T-Rex locked onto its prey, it went into attack mode, holding that lower jaw wide open. Its bite was so intense that its teeth could crush through bones immediately. When facing larger prey, it would use its colossal feet and claws to immobilize the victim. Once the prey weakened from blood loss, T-Rex would grip its neck or flank between its teeth, then give a head jerk, tearing out massive chunks of meat. Now, surprisingly, evidence suggests that this massive creature could swim, despite its enormous size. Although primarily land-based predators, T-Rex and similar dinosaurs classified as theropods possessed bird-like hind limbs. These limbs, designed for walking and running, could also facilitate swimming through a robust kicking motion. Fossil records reveal score-like marks, known as swim traces, created by the claws of two-legged dinosaurs like T-Rex as they swam across lakes, rivers, and seabeds. Moreover, detailed examination using CT scans on fossilized skeletons indicates a hollow bone structure in many theropods. This structural adaptation would have contributed to the buoyancy of their massive bodies, supporting the hypothesis that Tyrannosaurus Rex was capable of swimming. It probably made use of this behavior to broaden its feeding opportunities, and despite what you might think, the large size of T-Rex wouldn't be a hindrance to its ability to swim. Here's why. Observing present-day examples, some of the heaviest animals are known to swim, including modern relatives of T-Rex, such as giant flightless birds like ostriches and emus. These birds, with a body shape similar to T-Rex, display impressive swimming abilities, even making sea crossings of several miles to access new food sources on offshore islands. But even with these capabilities, venturing into coastal waters 66 million years ago would not have been without risks for T-Rex. The presence of aquatic predators like Mosasaurus, known to hunt beneath the waves, would have posed a threat to it, particularly the young ones, making them potential targets for these dangerous aquatic hunters. So, while T-Rex might have been good swimmers, they likely only made short trips to the ocean, because with Mosasaurus patrolling the coast, there's no way they could dominate the waves. To wrap it up, T-Rex was certainly the biggest two-legged predator in the late Cretaceous ecosystem, and it was one of the largest predators ever to live on land. This dinosaur killer is one of the most misunderstood dinos of all time. The real-life Velociraptor was a dromaeosaurid theropod dinosaur that roamed the Mongolia-China border during the late Cretaceous period. Now, contrary to its cinematic portrayal, this guy was no larger than a wolf and boasted a bird-like appearance with its feathered covering. But wait, since it had feathers, does that also mean it could fly? Stick around to find out. The very first Velociraptor fossil was found in 1923 during an American Museum of Natural History expedition in the Gobi Desert. This desert is in southern Mongolia and parts of northern China, and back then it was one of the most remote places on Earth, only reachable by reliable vehicles and trustworthy horses. Despite its isolation, the Gobi Desert held great potential for dinosaur fossils. Roy Chapman Andrews led this adventurous expedition into a desert area called Jadokta. In 1923, his team found the first ever nest of dinosaur eggs. During these expeditions, the team stumbled upon the Velociraptor. They discovered an impressive claw alongside a complete, although crushed, skull. The claw, about 176 millimeters in length, was initially thought to belong to a different dinosaur. However, the president of the American Museum of Natural History published drawings in 1924, declaring it was a claw from a new dinosaur, and named it Velociraptor mongoliensis. This translates to speedy thief from Mongolia or quick plunderer. Osborn recognized the dinosaur as a swift predator, and the name Velociraptor, a combination of Latin words meaning swift and thief or plunderer, quickly became the official name. There are two known species of Velociraptor. The first one, Velociraptor mongoliensis, was discovered in the Gobi Desert back in 1923. The second one, Velociraptor osmolskae, was identified in 2008. Now, what sets these two species apart? Well, there are many similarities, such as a large teardrop-shaped hole in their skulls. However, enough differences were found in the serration and structure of their teeth to classify Velociraptor osmolskae as a distinct species. This discovery raises interesting questions for paleontologists. Why did two different species of Velociraptor develop? Well, it could be due to slight differences in plant life between the Bayan Mandahu and Jadokta formations. There's a theory that the two species lived at the same time, but were separated by some geographical barrier. The Velociraptor was quite small for a dinosaur, usually measuring around 6 feet, 1.8 meters long, and weighing less than 100 pounds, 45 kilograms. Its body was streamlined and lightweight, designed for swift movements, which made it a skilled predator. With its long, narrow head and relatively large brain, it had a sleek appearance, and its snout was somewhat flat. Its jaws packed rows of sharp, jagged teeth, perfect for tearing through flesh. In 2007, scientists confirmed that Velociraptor sported feathers, adding an interesting dimension to its appearance, and likely helping it regulate body temperature or display for mating. However, despite the presence of feathers, its arms were too short to facilitate flight, so it probably remained firmly grounded while chasing prey. Now, the Velociraptor was a bipedal dinosaur, meaning it walked or ran on its two hind limbs standing upright. Its legs were strong and ended with the iconic sickle-shaped claw on the second toe of each foot. This claw was incredibly flexible. Initially, scientists thought Velociraptor used this claw to slash open its prey in one swift motion. However, further studies suggest it was more likely used for stabbing and gripping its victims, similar to how modern birds of prey use their talons. The sickle-shaped claw was held high while the dinosaur moved, probably to keep it sharp and ready for action. Its forelimbs were relatively long and ended with hands capable of grasping, each sporting 3 clawed fingers. The tail, rigid due to bony rods along the vertebrae, helped Velociraptor maintain balance while running or attacking prey with its single-shaped claw. This guy's speed, agility, and lightweight build made it a formidable predator, capable of some pretty quick moves when chasing its prey. These qualities earned it the name Velociraptor, meaning quick plunderer. It primarily hunted small plant-eating dinosaurs, often launching surprise attacks from the cover of vegetation. Due to its size, it preyed on small mammals, reptiles, amphibians, and insects, opting for anything that was easy to overpower and kill. Additionally, they occasionally targeted small infant dinosaurs, like young Protoceratops, baby oviraptors, and little Prenocephalae, showcasing their opportunistic feeding habits in their local ecosystems. Like all dinosaurs, Velociraptor likely reproduced by laying eggs. It probably stayed with its nest to protect its eggs and offspring. Fossils of another meat-eating dinosaur, Oviraptor, found in a nest with eggs and young, have sparked debates among paleontologists about parental care among dinosaurs and their close relatives. The potential mating behavior of this species might have involved displays of size, gestures, vocalizations, body language, and perhaps even synchronized dances between mates. Moreover, the Velociraptor possessed numerous sharp, pointed teeth in both its upper and lower jaws, lacking a beak seen in some dinosaur species. These teeth featured intimidating serrations with sharp edges on each tooth, intensifying from the front to the back of its mouth. To maintain its sharpness, Velociraptor's teeth were continually replaced throughout its life, similar to the Tyrannosaurus Rex. Additionally, the teeth of the Velociraptor curved backward, providing a practical advantage for gripping prey and preventing its escape. The narrow jaws and compact build suggest a preference for smaller prey, confirming the carnivorous nature of the Velociraptor. Now, this amazing creature had a robust skull, relatively large for its size at approximately 23 centimeters or 9.1 inches. Its box-like skull featured a long, narrow snout, constituting about 60% of the entire skull, ideal for capturing swift prey with quick, snappy bites. While popular culture such as Jurassic Park portrays velociraptors as highly intelligent creatures capable of opening doors, their intelligence likely paralleled that of an average cat or dog, falling short of the intellect attributed to dolphins or primates. This assessment is based on the encephalization quotient, which compares brain size to body size, indicating relatively high brain size in velociraptors compared to other animals, including dinosaurs of the time. There are also indications suggesting velociraptors might have been nocturnal. This is supported by the presence of a large sclerotic ring, which is a bony ring inside the eye socket that typically accommodates enhanced night vision by allowing more light into the eye. There's research suggesting that predatory dinosaurs like velociraptors and microraptors were primarily nocturnal, with exceptions like cathameral dinosaurs, which were active in short bursts during the day. This theory aligns with the behavior of modern carnivores, most of which are nocturnal. While ongoing studies continue to reveal more about this research, it sure as heck challenges the conventional portrayal of dinosaurs hunting and living predominantly in broad daylight. In reality, the dinosaur world may have functioned around the clock. Velociraptor, along with other carnivorous dinosaurs from Central Asia during the late Cretaceous period, were adorned with fine feather-like coverings. Paleontologists have compelling evidence supporting this conclusion, and it's not exclusive to Velociraptor alone. Close relatives like Microraptor and the Congoraptor also exhibited feathers. In 2007, a Velociraptor forearm specimen revealed imprints of quills, indicating the presence of 14 long feathers extending from its second finger to its arm. These feathers likely served to regulate body temperature. Furthermore, Velociraptors might have employed their wings to shield nests, like some of our raptorosaurs found fossilized in protective positions over their eggs. Wings could also have helped manage nest temperatures and facilitate quick maneuvers, generating speed on inclines through negative lift. Feathers might have also been used for display purposes, potentially attracting mates, similar to modern birds. Now, while velociraptors possessed fused wishbones and collarbones, resembling those of modern birds, their wings weren't suitable for flight due to their symmetrical nature and insufficient size to support the dinosaur's body weight. But there are some studies that suggest velociraptors may have had ancestors capable of flight. However, they probably lost this ability through evolution. This scary little dino came equipped with a lengthy tail, and it probably utilized this feature to maintain stability while running at high speeds. The tail, comprised of rigid fused bones, acted as a stabilizing mechanism during the velociraptor's pursuits and hunts. Contrary to the traditional belief that the tail was inflexible, a recent specimen displayed intact vertebrae arranged in an S shape, suggesting a degree of flexibility. With muscular legs and its impressive tail, estimates suggest that the velociraptor could reach speeds of 40 kilometers per hour or 24.85 miles per hour in short bursts. This velocity surpassed that of humans and its potential prey, adding a formidable aspect to its hunting prowess. However, it's noteworthy that while Velociraptor was swift, it did not hold the title of the fastest dinosaur. Ornithomimosaurs, likely running in a manner similar to ostriches, are estimated to have achieved speeds of 70 kilometers per hour or 43 miles per hour. There is minimal evidence supporting the idea that velociraptors or any dromaeosaurs engaged in pack hunting. The concept of pack behavior in hunting is a sophisticated behavior observed in very few mammals, as mammals in general are considered intelligent. The common depiction in paleo art of large dinosaurs being instantly besieged by groups of Deinonychus is not well supported. The basis for this notion comes from a bone bed where several Deinonychus individuals were found grouped together, apparently feeding on a deceased Tyrannosaurus. This could indicate group hunting, but it's also possible that the prey animal died from other causes and unrelated Deinonychus opportunistically gathered to feed. Considering the nature of these dinosaurs, the latter scenario seems more plausible. When we look at how these dinosaurs behave, it seems more sensible to think that they were competing for food rather than hunting in packs. Even though we might be tempted to link intelligence with pack hunting, it's not so clear when it comes to raptors like Velociraptor. In Jurassic Park, the idea of smart raptors challenges the old beliefs that all dinosaurs were not very smart. People used to think dinosaurs were dumb because they were considered reptiles, and reptiles were usually not seen as very bright. But dinos like Velociraptor and others faced a bit of a bias. Scientists named parts of their brains like mammals, making it seem like they used less smart structures. It might sound confusing, but it just means that they assumed birds and some dinos, like Velociraptor, used simpler brain structures for thinking. So, the idea of super smart raptors doing complex things like hunting together still needs more proof. There are a few ways to guess how smart animals might be. We can check their brain-to-body ratio or count their neurons, but these methods aren't perfect when predicting intelligence. They mainly give us general ideas, and with animals that lived a long time ago, it's even trickier because we can't directly test how smart they were. This is why Jurassic Park made a point of including intelligence as a mystery. We had no way of knowing how clever dinosaurs really were going to be. Looking at the brain case of Velociraptor, it's been studied, and it seems quite similar to what we see in Archaeopteryx. We can say that more of their brain was used for smelling compared to birds, and they didn't have a specific structure for processing visual and touch information, which makes sense since they couldn't fly. However, when it comes to their problem-solving skills, it's something we might never know for sure. In the end, the Velociraptor, with its sharp, serrated teeth, feathered coverings, and vicious jaw, thrived in the diverse, fossil-rich landscapes of Central and Eastern Asia. As a warm-blooded, agile predator, this relatively small dino utilized its speed and intelligence to hunt small prey and survive in dry environments. This is the tale of a shark twice the size of the most ferocious dinosaur known to mankind. Yes, the T-Rex. With 5 rows of 250 teeth, each the size of a banana, this gigantic shark would have been the nightmare of humans and beasts alike. Its jaws were strong enough to crush cars and big enough to swallow multiple humans in a single bite. That was the Megalodon, and its name literally meant giant tooth. But there was a lot more to this behemoth than just giant teeth. Megalodon was not only the biggest shark to ever exist, but it was also one of the largest fish in the history of the world. And to top it all off, it also has the strongest bite force of any animal in history. Let's start off with its physical appearance. Now, the Megalodon is classified as a mackerel shark, so it's possible that the Meg's shape and general form would have been similar to that of typical sharks we see today. In terms of its physical appearance, the Megalodon has been compared to different shark species, including the great white shark, the basking shark, the whale shark, and the sand tiger shark. Whether or not it actually resembled these sharks, we'll never know, but based on comparisons, it's thought that the Megalodon had a streamlined and elongated body tapering towards the tail, and was equipped with powerful fins to propel it through the water. Its jaws may have been blunter and wider compared to that of the great white, but the fins were probably similar in shape. On the other hand, if the Megalodon was more similar to the basking shark or whale shark, it means it would have had a crescent-shaped tail fin paired with a small anal and a second dorsal fin. But the most controversial aspect of the Megalodon's appearance is its size. 'Cause sharks are made up of cartilage, and cartilage does not fossilize. So all we have on the Megalodon are fragmentary jaw bones and tooth fossils. Based on these fossils and a few fossilized vertebrae, the maximum total length of this magnificent creature was calculated to be between 47 to 67 feet, or 14.2 to 20.3 meters. That's bigger than even the largest T-Rex. The average length, though, was found to be around 34 feet, or 10.5 meters. However, this is the estimate when comparing it to a great white shark, which isn't exactly correct. Research on an incomplete set of Megalodon vertebrae showed that it couldn't possibly have supported the body shape of a great white. The combined length of the vertebrae turned out to be less than the estimated total length of the Megalodon, which couldn't be possible. That's because the original estimates were made by comparing it to the broad, bulky body of a great white shark. Now we've realized that Megalodons would have actually been better suited for a longer, more slender body. So yeah, the Megalodon could have been even bigger than our current estimates. But until we get more fossils, these are the numbers we're going to go with. And based on these estimates, the Megalodon would have been about the same size or slightly bigger than the whale shark, which is the longest shark today, at about 62 feet or 18.8 meters for the biggest individual. However, you'll see in a while that this was the only similarity between the two. While the whale shark is a peaceful filter feeder, the Megalodon is the exact opposite. Still, one difference for now is weight, because Megalodon was unrivaled in that category. A 56-foot or 17-meter Megalodon would have weighed about 130,000 pounds or 59 tons, which is more than twice the size of the biggest whale shark today. And the biggest individual could have easily maxed out at about 250,000 pounds or 114 tons. This means that not only was Megalodon the biggest shark to have ever lived, but it also exceeded any of the biggest predators to have ever walked the planet or inhabited Earth's prehistoric seas. It was larger than the Spinosaurus, the T-Rex, or any massive theropod dinosaurs alive during the Mesozoic era. The Megalodon also exceeded some of the biggest marine reptiles discovered so far, including the Basilosaurus and Tyrannosaurus. You might be wondering why it grew to such huge sizes in the first place. That'll all become clear when you see the giants it had to compete with, so stay tuned till the end to see them for yourself. For now, its size tells us at least one thing. A creature this big would have taken over the whole planet, and not surprisingly, it actually did. Megalodon had a very wide geographic range during its existence. Fossils of the Megalodon have been recovered from every continent except Antarctica, meaning it had a global distribution. However, it is more commonly found in tropical and subtropical climates. In fact, scientists have been able to determine the likely conditions of this shark's habitat by studying its tooth fossils. Based on this, it has been determined that the Megalodon lived in waters within a temperature range of about 35 to 75 degrees Fahrenheit, or 1 to 24 degrees Celsius. That could only be possible if the Megalodon was warm-blooded. Yes, unlike most sharks and even most fish, Megalodon could control its temperature internally and not depend on the environment. Plus, it exhibited mesothermy, which is the ability to keep its body temperature higher than its surroundings by conserving metabolic heat. Because of this, the Megalodon would have been able to endure and survive in low temperature conditions. As a result, Megalodon was able to thrive in a wide range of habitats. This includes shallow coastal environments, swampy lagoons, continental shelves, and deep offshore areas. But just because it survived everywhere does not mean the environment had no effect on it. Fossils of the Megalodon discovered so far show that the average body size of the shark varied from one region to the other. Generally, specimens discovered in the southern hemisphere tend to be larger on average compared to those found in the northern hemisphere. The average length of the Megalodon specimens discovered in the northern hemisphere is about 31 feet or 9.6 meters, while those from the southern hemisphere were about 38 feet or 11.6 meters long. A similar variation is seen for individuals that lived in the Pacific and Atlantic Oceans. The Pacific Megalodons were bigger, with an average length of about 36 feet, 10.9 meters, compared to 31 feet or 9.5 meters for the Atlantic Megs. Whatever the size though, one thing is clear: Megalodon ruled wherever it went, and that's obvious from its 20 million year long reign. Megalodon lived during the Cenozoic era from the early Miocene to the Pliocene epochs, approximately 23 to 3.6 million years ago. And the climate for this time couldn't have been better for this gigantic shark, since it was generally warmer than it is today, with fluctuating temperatures from time to time. But while the Earth experienced a relatively warm climate during the early Miocene, it gradually cooled during the late Miocene and into the Pliocene. These temperature changes probably affected the distribution and abundance of various marine species, including the Megalodon and the animals it preyed on. In fact, it could have influenced the Megalodon so much that it probably became the cause of its extinction, but more on that later. For now, let's focus on the time it did enjoy terrorizing the oceans, because almost no marine animal was safe from the Meg. This is simply because Megalodon was a very highly specialized and efficient predator, and the credit goes to its natural body structure. This shark had a streamlined body with a large and muscular tail, suggesting that it was an active swimmer capable of cruising through the water with great speed and agility. In fact, scientists have been able to estimate a top speed for Megalodon based on its proposed body proportions and comparison to other living shark species. A cruising speed of about 3.1 miles or 5 kilometers per hour, has been proposed for the Megalodon. This is equivalent to a mean speed of about 0.09 body lengths per second for a 52-foot or 16-meter long Megalodon. At this pace, it moves similar to a sloth climbing through the trees. Now, this may not seem like a big deal, but the cruising speed in body lengths would have been greater than that of any living mackerel shark. It's actually quite simple. If you look at a great white shark, it's only 13 feet or 4 meters long on average, and its cruising speed is 5 miles per hour or 8 kilometers per hour. In contrast, the Megalodon, which is almost 5 times bigger, has a slightly less speed of 3.1 miles per hour or 5 kilometers per hour. So the Megalodon was obviously a much better swimmer, even 20 million years ago. That could also be why it's thought to be a solitary hunter, because let's be honest, if 2 Megalodons started hunting together, they'd wipe the ocean in no time. And you don't have to take my word for it. Research published in August 2022 estimated the Megalodon would have been able to devour prey the size of orca whales, which could be up to 26 feet or 8 meters long and weigh more than 8,000 pounds or 3 tons in just 5 bites. So it's safe to say Megalodon was not just an apex predator, but the king of apex predators. Its diet was probably made up of fish, baleen whales, toothed whales such as ancestral forms of modern sperm whales, dolphins, killer whales, sirenians such as dugongs and manatees, and seals. Seals and dolphins might make sense, but how could it possibly take on whales? Well, its massive teeth, shaped like broad triangles with serrated edges, were perfectly adapted for grasping and tearing apart large prey. Plus, the Megalodon's jaws were also huge, just like the rest of its body. In fact, they were so massive that they could swallow 2 adult humans standing side by side. In addition to being massive, the jaws were lined with up to 276 banana-sized teeth, each of which measured about 7.1 inches or 18 centimeters diagonally. So they were more knives than teeth. And luckily, we don't have to guess the kind of damage they could have done. In 2008, a group of scientists conducted an experiment to measure the bite force of an 8-foot, 2.5 meter long great white shark. They then used these measurements to estimate the bite force of a Megalodon by scaling the results to match its maximum size and conservative minimum and maximum body mass. They estimated that a Megalodon's bite force ranged between 100,000 to 180,000 newtons. In comparison, a modern great white shark has a bite force 10 times less than that, around only 18,000 newtons. And if these estimates are accurate, the Megalodon may have had the most powerful bite of any animal ever. Not even large carnivorous dinosaurs like the T-Rex or gigantic prehistoric crocodiles could have come close to this kind of bite. But natural advantages were not the only weapon in its arsenal. You could say the Megalodon was a born hunter, considering its highly effective attacking strategies. Unlike great white sharks that tend to attack prey by targeting the underbelly, Megalodon likely attacked large prey from the side, delivering a fatal and final bite to the heart and lung area. The shark's teeth were strong enough to bite through tough skin and bones and could inflict a fatal blow on even the biggest prey. And yes, we have actual proof of this. Fossils of large baleen whales from the Miocene epoch have been found with huge bite marks on the rib cages like this, and it doesn't take a genius to know which animal it could have come from. And based on multiple other similar fossils with bite marks on different parts, it's thought that Megalodons probably adapted their attack patterns based on the specific size of the prey they hunted. For instance, they probably rammed smaller whales with their blunt snout, disorienting them from delivering a fatal bite, while they killed sperm whales with a single bite to the head. It's also likely that the Megalodon immobilized larger prey by biting off parts of their flipper and tails before killing and feeding on them. Still, there were a few animals that wouldn't have gone down so easily in front of this behemoth. Think about it. Megalodon couldn't possibly have been the only behemoth in its habitat, especially considering everything was gigantic in the prehistoric era. The seals, dolphins, sea turtles, and sirenians in its ecosystem were certainly easy prey for this mammoth shark. But baleen whales like the 22-foot or 6.8-meter Cetotherium and sperm whales like the 20-foot or 6-meter Orlophyseta would have been easy targets. Then, there are also animals that would have fought back. These include the humongous macroraptorials of the time, which were carnivorous whales that ate just about anything in their sight, including other whales. The 23-foot-long or 7-meter Brygomypheceta shigensis was one of the smaller ones among these macroraptorials. The largest out of all macroraptorials, Livyatan, would have been every animal's nightmare. Some of the whales from this genus grew to a maximum length of about 57 feet or 17 meters, had the largest biting teeth of any known animal, longer than 1 foot, and targeted the same prey species as the Megalodon. However, the massive size of the Megalodon would have given it an edge over these predators, so while it may have fought these animals for prey or defense, it's certain that adult Megalodons did not become prey for any animal in history. The young Megalodons, though, would have had a harder time, since it's thought that they were likely preyed on by other large predatory sharks, like great hammerhead sharks, which existed in the same time period and regions. As for adult Megalodons, the only animals to take on them head-to-head were other Megalodons. Yes, these sharks, like modern sharks, may have competed against each other, and also may have exhibited cannibalism, with larger individuals preying on smaller ones. This would have been especially true for young Megalodons, way before they started swimming in open waters. See, unlike many fish that simply lay eggs, lamniform sharks like the Megalodon have a different reproductive method. Their eggs hatch inside the mother's body, and the young sharks stay there until they're big enough to survive on their own. During the prenatal growth period, the baby sharks need to eat to grow. The only problem is that everything looks like food to them, including their own siblings. So instead of finding food outside, they eat the eggs inside their mother's body. If their siblings hatch before them, they eat their siblings too. Sharks are known for being ferocious eaters, and baby sharks are no different. We don't have any direct evidence from fossils to prove that baby Megalodons behaved this way, but it's likely they did. The massive size of adult Megalodons supports this idea. This enormous size was probably both a cause and an effect of the evolutionary pressures in the prehistoric ocean ecosystem. Given their size, each embryo would have needed significant space and resources to thrive, and cannibalizing other embryos would have given them more room to grow. So, it seems like these beasts were literally willing to do anything to survive. But if they were willing to go to such extreme measures, how on earth did they go extinct? Around 2.6 million years ago, the Megalodon disappeared, and there are a few possible reasons for this extinction. This period marked the beginning of the Pleistocene, also known as the Ice Age, characterized by cooler temperatures and long periods of glaciation. These climate changes could have directly affected the Megalodon or impacted its food sources. The shift in climate led to a restructuring of whale habitats. As the environment changed, more productive areas with abundant food formed closer to the poles, making whales more migratory and spending more time in these colder regions. This could have posed a problem for Megalodon if its prey moved to waters too cold for the shark to follow. For a long time, scientists believed this change in whale behavior might have contributed to the extinction of the world's biggest shark. But as you already know, Megalodons were mesothermic and could survive at even an extreme temperature of 34 degrees Fahrenheit or 1 degree Celsius. So if changes in whale movements and habitats weren't the primary problem for Megalodon, then what was? Well, the timing of Megalodon's disappearance coincides with two significant changes in the animal kingdom. One was the emergence of new predators that it had to compete with. Around the middle of the Miocene, the biggest Livyatan species, Livyatan melville, appeared. And if you're a Moby Dick fan and wondering where you've heard the name before, it's literally the same deadly whale from the novel. Livyatan had short, powerful jaws and big, strong teeth designed for biting into flesh. At 57 feet long, or 17 meters, this whale wasn't just eating squid, it was preying on other whales. And Livyatan was just one among many carnivorous whale species during the Middle Miocene. In the late Miocene, another competitor appeared in the fossil record, the earliest ancestor of the great white shark, Carcharodon habeli. This shark was a direct competitor to the Megalodon as evidenced by tooth marks found on fossils of the same whale species that the Megalodon ate, such as the small whale Piscobalaena. A few million years later, in the early Pliocene, the first fossils of the modern great white shark, Carcharodon calcareus, emerged. Megalodon now had to compete with these newer, more agile sharks. At the same time, some of the Megalodon's most important prey, particularly whales, were in decline. By the end of the Pliocene, the number of whale species decreased dramatically from about 60 to 40. Many of these whales were filter feeders that relied on krill, which in turn fed on microscopic algae called diatoms. Around 3 million years ago, there was a significant drop in diatom diversity in the oceans. In simple words, fewer diatoms led to fewer krill, resulting in fewer whales. With less food available, Megalodon had to compete even more fiercely with the smaller, faster great white shark. Being larger is advantageous when it provides access to a different food group, but when it doesn't, it just means requiring more food to survive. Consequently, around 2.6 million years ago, the last of the Megalodons disappeared from the fossil record. However, like the disappearance of whales left a lasting mark on the Megalodon, its own disappearance left an even more lasting mark on all marine life. These are changes that we are still experiencing today as part of Megalodon's legacy. In order to understand this, we gotta trace our steps back to the time the shark went extinct. As a result, in the last couple of million years, great white sharks and orcas took over the role of apex predators. However, these much smaller predators couldn't hunt the larger whales that Megalodon could eat. Modern great white sharks often prey on dolphins half their size, so it's possible that the 18-meter Megalodon was able to hunt whales up to 9 meters long, which was simply too large for other predators to handle. Consequently, after the Megalodon went extinct, the size of whales dramatically increased. During the Pleistocene, the oceans became colder and productivity at the poles improved, leading to a resurgence of diatoms. This new, productive environment, combined with the absence of large predators, allowed whales to grow to sizes twice as large as the biggest whales of the Pliocene. This is why the blue whale, the largest animal ever, appeared in the fossil record less than 2 million years ago. Without 18-meter sharks like Megalodon, the oceans could support 25-meter whales. The Megalodon and its ancestors had a successful run, thriving for over 20 million years by evolving to eat larger marine mammals. However, as those large mammals began to decline and competition with other predators like great white sharks increased, the Megalodon could not keep up. It's interesting to note that the largest great white sharks today are about a meter longer than their Miocene ancestors and grow faster while they are young, much like Megalodon did. It took nearly 30 million years for the mega-toothed sharks to evolve into the enormous Megalodon, a transformation driven by the gradual increase in the size of whales and other marine mammals. Today, whales are already huge and face very few predators, leaving the role of a super shark open. Who knows, the great white shark could very well evolve into the Megalodon of the future, and giant sharks might once again patrol our oceans. And that's a wrap. Which prehistoric fish scares you more, the merciless Megalodon or the terrifying Leviathan? Drop your thoughts in the comments below. And if you enjoy learning about ancient creatures, make sure to hit that subscribe button and stay tuned for more cool stuff about the past. The biggest, baddest meat-eating dinosaurs of all time. Measuring somewhere between 14 to 18 feet long, the Spinosaurus aegypticus was actually bigger than the T-Rex, almost the size of 3 killer whales. And yes, it makes a worse villain than the ferocious T-Rex too, cause this guy could swim. It was like a freaking Godzilla surfacing from shallow water bodies. Many believe it could weigh up to 31,600 pounds, which makes it almost as heavy as the Mosasaurus. The teeth were no joke either, with 64 teeth, some reaching up to 5 inches long. But even with its huge size, it was actually pretty fast. In fact, it may have been able to run at speeds of up to 15 miles per hour, which is 2 times faster than the average human. Now, let me take you back to 1912, when paleontologist Richard Mara stumbled upon the first Spinosaurus in Western Egypt. His buddy Ernst Stromer gave it the name we know today in 1915. This discovery was a big deal, showing off that crazy spine. But tragedy hit in 1944 during a bombing raid in Munich, Germany, wiping out the Spinosaurus specimen. Luckily, Stromer's son saved the day by donating his dad's archives in 1995. Despite the setback, scientists keep hunting for other Spinosaurus specimens throughout history. And then it finally happened 100 years later. Paleontologist Mizra Ibrahim, working on his doctorate in Morocco, had an insane encounter. A local fossil collector handed him a box of fossils, and one particular piece caught Ibrahim's attention. It resembled Stromer's illustration of a Spinosaurus spine. Ibrahim was obviously intrigued and persuaded the collector to guide him and his team to the original fossil site. And that's when they hit the jackpot at a cliffside in the Kemkem fossil beds. They found hind limbs, a chunk of the pelvis, various neural spines, and a significant portion of the lower jaw, likely from a juvenile Spinosaurus. The team went high-tech, taking CT scans of their newfound treasures and crafting digital models based on Stromer's original descriptions. Piecing everything together, they dropped a bombshell in 2014 with a published paper detailing their discoveries. Nearly a century after Stromer's first Spinosaurus description, paleontologists got a fresh look at this iconic dinosaur. And guess what? It turned out to be even weirder than anyone had imagined. But remember, this was just a juvenile. The biggest Spinosaurus on the block is represented by a colossal humerus known as NMC 41852, and it's more than 50% larger than the neotype. If we crunch the numbers using the model from Ibrahim's study and the densities provided by Larramendi, plus factoring in the size difference that the paleo artist Spino in Wonderland worked out with the neotype, we're looking at a Spinosaurus that was approximately 16.65 meters long and weighed around 14,340 kilograms. This makes it a contender for the title of the largest known theropod and the mightiest land-dwelling predatory animal, potentially giving Dinosuchus hatcheteri a run for its money. And apart from that, Spinosaurus was the only large meat-eating dinosaur with a prominent sail. The question is, why? Well, there are quite a few theories about the impressive 1.5-meter high sail on Spinosaurus's back. Some believe it had something to do with attracting mates, like a peacock showing off its feathers. Perhaps Spinosaurus males used to flaunt their sails to impress the ladies during mating season. But there's another theory that has a rather different explanation. What if the sail was actually a built-in temperature control system, soaking up sun by day and letting out heat by night? Sounds nifty, but turns out Spinosaurus might have been more of a warm-blooded creature. So this theory doesn't really work well in that case, does it? Well, there's another idea suggesting the sail was more like a camel's hump, a fat stash for lean times. But didn't Spinosaurus live in lush, wet habitats, not deserts? Doesn't quite add up, does it? Now, here's a recent theory. Spinosaurus may have pursued a semi or almost fully marine lifestyle, swimming around in the rivers of northern Africa like a giant crocodile. If this is in fact the case, then there's a possibility that the sail of Spinosaurus was some kind of marine adaptation, possibly helping it navigate. Biologists figure the sail was probably a showstopper for courtship, but it might have had backup jobs like keeping cool, storing fat, or even helping with navigation. With Spinosaurus fossils still scarce, the mystery will continue to linger. However, recent studies suggest that Spinosaurus, unlike most large theropods, likely moved around on all fours, making it an obligate quadruped. This fresh perspective, backed by a new study, shifts the center of gravity forward, suggesting a smaller pelvic girdle, and highlights hind limbs adapted more for paddling than traditional bipedal walking. Speaking of limbs, a major problem with modern Spinosaurus depictions is that they often give it ridiculously short hind legs. The anatomical info, including Wikipedia's take, indicates that when fully stretched out, the hind legs were a bit over 25% of the entire body's length. Considering the estimated 14-meter length of an adult Spino, that translates to legs measuring 3.75 meters from hip to toe, and that's on par with other theropods like T-Rex, Carcharodontosaurus, and Giganotosaurus. But strangely, artists keep portraying Spinosaurus with legs nearly half as short as they likely were. Not cool, you guys. Spinosaurus holds the title for the largest known carnivorous dinosaur, surpassing even Tyrannosaurus in size. Its impressive stats include a skull measuring around 1.75 meters, approximately 6 feet in length, a body stretching between 14 to 18 meters, 46 to 59 feet, and a hefty estimated weight ranging from 12,000 to 20,000 kilograms, 13 to 22 tons. But here's what really makes the Spinosaurus stand out. Its skull resembles that of a crocodile, with nostrils positioned near the eyes instead of at the end of the snout. Unlike other theropods, its teeth are straight and conical, perfect for snagging fish. Moreover, its skeleton boasted compact, dense bones. Unlike similar land-dwelling theropods, this feature gave it better control underwater, leading some scientists to argue that Spinosaurus was more of an aquatic predator than a landlubber. But what has really surprised researchers is this creature's tail, with its peculiar caudal vertebrae. These vertebrae displayed exceptionally tall neural spines on top and extended chevrons underneath, indicating that Spinosaurus had even more spines than previously understood. Notably, the fossils appear to be from a single individual, a rarity in the Chemchem beds, making the reconstructed tail reliable and not a composite. This discovery suggests that the paddle-like structure of the tail is indicative of an adaptation to aquatic environments. Similar to living crocodiles and newts, it is proposed that this tail was used to propel Spinosaurus through the water. Moreover, bone reduction towards the tail's tip enables increased flexibility, allowing for side-to-side movement. This finding adds clarity to the debate regarding Spinosaurus's aquatic abilities, strongly supporting the notion that its unique tail evolved for efficient movement in water. Now, these guys roamed the Earth from around 99 to 93.5 million years ago, during the late Cretaceous period. Their stomping grounds were likely in North Africa, and they likely lived in places like tidal flats. They're muddy or marshy spots that the sea covers, as well as mangrove forests. The weather was no joke either. During the hottest times of the year, there were some serious droughts, causing many lakes and rivers to dry up. This tricky situation might have nudged Spinosaurus into playing the role of a land predator every now and then. It coexisted with several other large predators like Carnotaurus and Velociraptor, as well as smaller ones like Rugops and Deltadromeus. There were also other dinosaurs around, like the ornithopod Tyrannosaurus, the titanosaur sauropods Periotitan, and Egyptosaurus. With all that competition around, the Spinosaurus likely had a taste for fish munching, on a menu of giant coelacanths, sawfish, hefty lungfish, and even sharks that cruised in its river habitat. The design of Spinosaurus's skull kinda screams fish eater, pointing towards its likely prey choices. Now, this preference for fish is not just anatomical speculation. A 2010 study in the journal Geology, utilizing chemical analysis, supports the idea that fish were a major part of Spinosaurus's diet. But, interestingly, a tooth from another member of the Spinosauridae family, Irritator chalengeri, was found embedded in the remains of a Cretaceous pterosaur, a flying reptile, in 2004. This discovery hints that these fish-loving Spinosaurs might have also dabbled in hunting or scavenging non-aquatic creatures. Now, this is highly probable, because we do have some pretty heavy evidence to support this claim. A Spinosaurus tooth found lodged in the vertebrae of Carnotaurus, suggesting it fought and preyed on large theropods, comparable to the mighty Tyrannosaurus. Moreover, in a 2023 abstract focusing on the feeding habits of Spinosaurus, it was uncovered that Spinosaurus packed quite a punch, with a bite force exceeding 20,000 newtons, coupled with a robust skull. While its bite force fell within the typical range for large theropods, what set it apart was its extremely strong cranium and rostrum, showing resistance to stress during biting. Surprisingly, the stress on Spinosaurus's cranium was pretty darn similar to that experienced by Tyrannosaurus, and that really tells you how ruthless of a predator it must have been. This amazing giant went extinct about 95 million years ago, during the Cretaceous period. The exact reasons for its extinction aren't entirely clear, but experts think it might have been because of changes in the environment, competition with other species, and maybe even natural disasters. Here's a likely explanation. The Spino was highly adapted to swampy and water-based environments, but when these habitats dried up, even with its varied diet, it couldn't survive without its specific ecosystem. However, it is unlikely that Spinosaurus perished like other dinosaurs of its time due to a massive meteor impact. Instead, scientists suggest its extinction resulted from an extreme drought, which occurred before the mass extinction event. Evidence supporting this theory comes from the discovery of Spinosaurus bones in the Egyptian desert. Its body was well suited to wetlands, with features like its long snout, specialized for detecting fish underwater. However, in the new dry environment, these adaptations became less useful. For example, its snout wasn't as effective at detecting the scents of other dinosaurs compared to its ability to find fish. And what's more, the Spinosaurus had lighter bones than other dinosaurs, which might have posed challenges in adapting to the changing conditions. In the end, the Spinosaurus was the largest carnivorous dinosaur, standing as the top predator of its time. With straight teeth and the ability to swim making it a remarkable aquatic and land predator, it's amazing that there's still so much left to discover about this Egyptian spine lizard. Given that a lot of its bones still remain undiscovered, who knows what other secrets might surface very soon. Back in the Jurassic period, around 195 million years ago, Dilophosaurus ruled North America as one of the top predators. Now you may remember it best from the movie Jurassic Park, where it's shown as a venom-spitting beast with a rattling frill around its neck and two paddle-like crests on its head. But the reality of this dinosaur is far from looking like a lizard. It's more like a bird, except it's massive. And I mean 8 feet tall, 25 feet long kinda massive, making it the largest dinosaur of its time. The word Dilophosaurus itself translates to double-crested lizard in Greek, and it really makes you think, why on earth would it be called that? Well, stick around and find out. Turns out it gets its name from the rather funny headgear it sported. Basically 2 slender, bony crests extending from its snout to behind its eye socket. Although the actual shape of these crests remains uncertain because they were likely covered in keratin, the same material as rhino horns, it's believed that they were probably brightly colored and served as an attention-grabbing display for potential mates. There's even a possibility that these crests had inflatable air sacs on top, similar to modern birds, to make them look more handsome. But what's even more fascinating is that paleontologists have found that these crests and other bones were strengthened with air pockets arranged in a honeycomb structure. This unique design made the skeleton both robust and lightweight, allowing Dilophosaurus to achieve a larger size compared to other dinosaurs. Now rewind the clock back to the late Triassic in western North America, and most dinosaurs were no bigger than turkeys or eagles. But the Dilophosaurus wasn't there to fit in. It was way bigger than how it was shown in the movies. In fact, the largest ones weighed around 1,500 pounds, similar to an adult polar bear. In the early Jurassic era, when dinosaurs were becoming the big shots on land, Dilophosaurus stood out as one of the largest predators. Although not as massive as the later Tyrannosaurus and Carnotaurus, crossing paths with a Dilophosaurus would still have been a pretty serious threat for a human. What makes it even more unique is its longer and stronger arms compared to other large meat-eating dinosaurs like Allosaurus and Ceratosaurus. Even its legs were relatively longer. When scientists first stumbled upon Dilophosaurus skeletons, they thought it was related to the so-called carnosaurs like Allosaurus and Streptospondylus. They even filled in the missing pieces of the pelvis to match those animals. But as more well-preserved Dilophosaurus skeletons came to light, it turned out to have a pelvis anatomy that falls somewhere in between the Coelophysis-like creatures from the late Triassic and the Allosaurus-like ones from the late Jurassic. Moreover, the Dilophosaurus skull has this big gap in the upper jaw, right between its front teeth. Surprisingly, this gap is like a weak spot in its skull. It hints that Dilophosaurus probably didn't have a strong bite compared to other dinosaurs of similar size without this gap. One idea is that this gap might have helped Dilophosaurus grab small prey from tight spots like rock crevices. But considering it was a massive 25 meters long, that doesn't seem like the most efficient way for such a big dinosaur to eat. Another theory is that Dilophosaurus wasn't much of a hunter, but more of a scavenger. In this scenario, it would only need a bite force to rip meat from a dead animal, using its size to scare off smaller carnivores from their meals. So, that gap in Dilophosaurus's jaw might not be the key to understanding its eating habits after all. Even though there were other dinosaurs around that Dilophosaurus could have hunted, it's possible it used its sharp claws for hunting instead. The gap might have been handy for picking meat off bones, since Dilophosaurus could have struggled with crunching bones due to its weaker bite force. Interestingly, a smaller version of this gap is also found in an earlier dinosaur called Coelophysis. Some scientists think that Dilophosaurus and Coelophysis might be related, with Dilophosaurus possibly evolving from Coelophysis. But there are so many ways Coelophysis could connect to other dinosaurs that it's tough to pinpoint the most likely scenario. When they first found Dilophosaurus in 1942, they didn't have the head crests, so they named it Megalosaurus weatherilli. It took over a decade and another more complete discovery, one with those distinctive crests, to realize that they had a different dinosaur on their hands. But what's even more interesting is that they found 3 Dilophosaurus buddies together, hinting that these dinosaurs might have roamed in packs. Dilophosaurus now has its own special category in the dinosaur family, called Dilophosauridae. Now, what exactly made the Dilophosaurus so darn fierce? Well, it had some pretty cool features to help it catch prey and deal with other dinosaurs. But the most important weapon it had was its big, vicious jaws. The jaws and skull were quite big compared to its body, making up about 10% of its length. This gave it enough room for around 30 teeth, which were all long, curved, thin, and squished sideways. Each tooth had a bunch of small, sharp edges called serrations, with some teeth having over 70 of them on both sides. These serrations made it easy for the Dilophosaurus to slice through flesh, causing quick blood loss and death for the unfortunate animals it hunted. And hey, forget about the whole spitting venom thing you saw in Jurassic Park. This dino, despite being on the heavier side, had a fail-proof way of catching prey: speed. It came equipped with killer legs, a light body, and some cool fleshy air sacs in its spine. Those sacs helped it breathe like birds and crocs do. Now, if being fast, having a killer bite, and a decent size weren't enough to rule its turf, there's a chance this dinosaur was a team player. Yep, some scientists think it could have been a pack hunter. In fact, they found 3 dino buddies buried together. Yep, we know quite a bit about Dilophosaurus's life thanks to some cool finds in the American Southwest. In the 1940s, 3 of them were discovered pretty close to each other. Now, we're not sure if they lived together and died in the same spot, or if they got there by water from different places. However, it isn't likely that they formed packs of more than 3, because given their size, that wouldn't really be sustainable. Moving on to its structure, Dilophosaurus skeletons stand out because its left arm is kind of underdeveloped, with a smaller upper arm bone, humerus, while the right arm is strong and sturdy. This difference might be due to tough living conditions and is a case of what scientists call fluctuating asymmetry. Most animals have bodies that are perfectly symmetrical, but when one part, like an arm, is different from the other, it's usually because of genetics or something external affecting it. In this case, it could be that Dilophosaurus faced some challenging circumstances that impacted the development of its left arm. Even with all the cool perks the Dilophosaurus had, being the Dino King wasn't a walk in the park. These guys were the battle-scarred champions of their time, often showing signs of wounds and diseases. The holotype, the poster child for the species, takes the cake, with the highest number of messed up bones among all theropods. It's got 8 bones that have seen better days, while the runner-up only has 4. Now, where did all these bumps and bruises come from? Well, it seems like their arms took the brunt of it, dealing with stuff like bony tumors, stress fractures, twists, and deformities. The poor holotype couldn't even properly use one of its arms. Imagine being a dino with one arm tied behind your back. Some scientists think these injuries might have come from failed hunts or throwdowns with other dinosaurs. What's wild though is that despite having banged up arms, a study of more than 60 Dilophosaurus found no fractures in their legs and feet. That just goes to show how crucial their arms were. And hey, these dinos were no wimps. The fact that they were running around with battle scars left and right just shows that they were the tough guys of their era. Living in a time when the Earth meant serious business, they probably had a massive pain tolerance. And what's more, despite the harsh environment and recent extinction events it went through, the Dilophosaurus thrived alongside other dinosaurs in its habitat. Some notable companions included Ceratosaurus and Megapnosaurus. The ecosystem was also rich in non-dinosaur species, such as hibernate sharks, bony fish, and lizards. But despite this diverse array of life, the Dilophosaurus stood out as the top predator in early Jurassic North America, thanks to its unmatched size and ferocity. In the end, it's safe to say that Dilophosaurus was a colossal predator that really defied all Hollywood stereotypes. With its impressive size, crazy powerful jaw, and speedy legs, it was the OG predator in an insanely diverse ecosystem. Definitely earned my respect. Imagine living in a world with a bus-sized, three-horn-faced dinosaur that could probably beat the crap out of a T-Rex. Yes, I'm talking about the mighty Triceratops. Weighing 22,000 pounds with 800 teeth and the largest skull among land mammals, this beast was a force to be reckoned with. Which is why in this video, we're traveling back 66 million years to Western North America where it lived. Surprisingly, even though Triceratops translates to three-horned face in Greek, it actually only had two real horns, each reaching up to 4 feet long. So then why would it be named the three-horned face? Well, what people might mistake for a third horn on its snout was more like a piece of soft protein called keratin, similar to our fingernails or hair. While it wouldn't have been much help in a fight, it certainly didn't put the Triceratops at a disadvantage. An adult Triceratops could stretch up to 30 feet long, stand 10 feet tall, and weigh a whopping 11 tons, which made it a bit larger than a full-grown male African elephant. And even though it was a plant eater, it wasn't one to mess with. Its massive body made it a beast you'd want to steer clear of. A single charge or a powerful swing of its horns could easily take down anything in its way. But hey, Triceratops wasn't just brawn, it had brains too. Its skull was one of the largest compared to its body size among land animals, which says a lot about how intelligent it really was. The biggest skull found was around 8.2 feet long, almost a third of the whole dinosaur. Now let me tell you the story of how Triceratops first popped up on the radar. Back in 1887, a fossil collector named George Lyman Cannon stumbled upon a pair of horns attached to a skull plate near Denver, Colorado. Excited about his find, he sent the horns to Professor Charles Marsh, a big shot in vertebrate paleontology at Yale University. Initially, Marsh thought it was just a prehistoric bison, but a year later, John Bell Hatcher found a more complete skull in Wyoming. That got Marsh rethinking things. And voila, Triceratops was officially recognized. Later, the Canadian Triceratops scene got spiced up in 1921 when Charles Mortham Sternberg discovered the first specimen, and later, in 1946, another find in Alberta was added to the mix. Fast forward to 2014, a group of researchers took a deep dive into over 50 Triceratops skulls from Montana's Hell Creek Formation. They looked at where the fossils were in the rocks and correlated it with changes in skull structure. And it turned out that Triceratops might have evolved from one species into another over 1 to 2 million years. Triceratops had a robust skeleton with strong limbs, short hands with 3 hooves each, and short feet with 4 hooves each. The backbone included 10 neck, 12 back, 10 sacral, and approximately 45 tail vertebrae. The neck bones at the front were fused into a single cervical structure. Now, as far as their posture goes, despite early beliefs, Triceratops and its horned dinosaur pals didn't have legs sticking out to the side. Instead, they kept an upright stance during regular movement, similar to modern rhinos. Their weight was supported by the first 3 digits, with the other 2 being more like hang-around digits without claws or hooves. These sturdy legs allowed for decent movement, but Triceratops wasn't breaking any land speed records. It could trot or gallop, maybe hitting speeds up to 15 miles per hour in quick bursts. Triceratops also had some pretty cool skin, covered in big scales, some even reaching over 3.9 inches across, with pointy projections in the center. There's also a preserved piece of skin from its frill, made up of small polygonal basement scales. Now, let's talk about its neck. It was a bit odd, I gotta say. Behind that imposing frill, there's a unique ball and socket joint at the base of the skull. This joint allowed the skull to rotate in any direction, giving Triceratops a 360-degree head spin. That flexibility was handy for finding food and could also be used for defense. That head, though, was quite hefty, about 30% of the length of the whole dinosaur. Comparing it to us humans, who have a more limited range of neck movement, Triceratops had a more flexible setup. Our ball and socket joints are in our hips and shoulders, not our necks. However, when it came to senses, Triceratops wasn't winning any awards for smelling. Its sense of smell was poor compared to other dinosaurs. But it had ears tuned to low-frequency sounds. The dinosaur liked to keep its head at a 45-degree angle to the ground, showcasing those awesome horns and frill while efficiently grabbing some grub through grazing. Speaking of grub, Triceratops was a herbivore with a low-hanging head, suggesting it mainly feasted on low-growing vegetation. Its jaws had a deep, narrow beak that was better for grabbing and plucking than biting. Now the teeth situation was interesting. Arranged in batteries, Triceratops had 36 to 40 tooth columns on each side of its jaw, with 3 to 5 stacked teeth per column. Tooth replacement was a constant thing throughout its life, with a range of 432 to 800 teeth in total. With its massive size and numerous teeth, Triceratops likely chowed down on large volumes of fibrous plant matter. Some researchers think it went for palms and cycads, while others lean towards a diet heavy on ferns in prairie-like environments. Now, let's talk about those iconic horns and frills. Initially thought to be weapons against big predators like Tyrannosaurus, evidence suggests they might have used them in some serious head-on encounters. Marks on Triceratops's brow horn and frill show battles with T-Rex, and a lot of paleontologists think Triceratops had the upper hand in these scuffles. But there are a lot of theories on what the real function of those fancy frills might have been. First off, the frill was most probably there for show-off. It wasn't super thick or strong, so it probably wasn't for protection. Instead, it was a display piece, a way for Triceratops to warn predators, attract mates, and show off its strength to fellow herd members. But the frill couldn't have been there only for the looks. It also provided a prime spot for jaw muscles to attach, being highly vascular. While it might have served a defensive purpose, most scientists lean towards it being more of a flashy display or competition tool. The idea that the frill helped regulate jaw muscle attachment hasn't gained much traction. But wait, there's a love story in the mix too. Some researchers believe the frill evolved as a result of sexual selection. Essentially, Triceratops with impressive frills were more likely to catch the eye of potential mates. Now, onto the practical side. It could have also been a temperature regulator. The frill and horn cores could have played a crucial role in stabilizing brain temperatures, especially in extreme weather conditions. And now, the blockbuster theory: defense against predators. While it's the coolest idea, think Triceratops versus T-Rex showdowns, it might not have been as common as you'd think. Triceratops' ancestors were more like house cats in size, and the epic battles you see in movies were probably rarer than we all wish. Moving on, Triceratops had a family life too, and while details about their love life are scarce, it's believed they laid eggs in nests on the ground. The young ones likely got some parental care for the first few years, showing rapid growth in different phases: babies, juveniles, subadults, and finally, adults. Fossil evidence reveals significant changes in their physical features during each stage, such as horn development and frill modifications. Speaking of families, clearly Triceratops wasn't a lone ranger. It belonged to a horned and frilled dino family called ceratopsids. These guys ruled the late Cretaceous lands, showcasing fancy frills, beak-like mouths, and impressive horns. Some, like Stegosaurus, had spikes on their frills, while some, like Protoceratops, kept it more low-key. But all of them, Triceratops included, were herbivorous herd animals roaming the late Cretaceous. Tragically, the reign of Triceratops came to an end around 66 million years ago. A colossal asteroid, approximately 7.5 miles wide, collided with Mexico's Yucatan Peninsula, causing an environmental disaster. This environmental disaster wiped out over 3/4 of Earth's species, including the mighty Triceratops and other non-avian dinosaurs. The impact marked the conclusion of the dinosaur era, changing the course of life on our planet forever. In the end, it's safe to say that Triceratops left an unforgettable mark on the late Cretaceous landscape of Western North America. From its robust body to its crazy mouth filled with teeth, it isn't a dino you'll be forgetting about anytime soon. And while its reign came to an abrupt end with the cataclysmic asteroid impact, Triceratops remains a symbol of the fascinating diversity of prehistoric life. Back in the late 1800s and early 1900s, some dinosaurs were taken out of the earth and have now become so famous that they've become a permanent fixture in pop culture. You know the ones, like the mighty Tyrannosaurus Rex, whose face you can find on everything from kids' toys to birthday cards, video games, and blockbuster movies. Yeah, he's pretty much the Kanye West of dinosaurs. But one guy you're missing out on is the Carnotaurus, the mighty meat-eating bull. The name kinda gives you the chills, doesn't it? Well, the looks are even scarier. Except for the teeny tiny arms, of course. Those really make you want to baby it. But apart from that, mean predator. Discovered in 1984, Carnotaurus belongs to the Allosauridae family, specifically the Carnotaurini tribe. It's got a pretty distinctive look, a short, deep skull, small arms, and long legs. Even though there's only one well-preserved Carnotaurus skeleton, it still stands out as one of the best understood Southern Hemisphere theropods. Living during the late Cretaceous in Argentina, Carnotaurus witnessed the aftermath of South America's separation from Africa. This isolation triggered independent evolutionary adaptations, much like the distinct wildlife of modern-day Australia. And based on that one solitary well-preserved fossil, it stood at about 10 feet tall and measured 25 to 35 feet in length. Not quite the giant like Disney's Dinosaur T-Rex, but still a hell of a predator. Soft tissue preservation revealed a creature with a sleek, thin build, a far cry from the bulky T-Rex. Its overall body design was a bizarre mix: a flat, almost bulldog-like skull, extremely long legs, a rigid muscular tail, and tiny, almost comical vestigial arms. But all other features aside, I want to start with the rather strange skull, shorter and deeper compared to other carnivorous dinosaurs. The question is, why did it have such a distinct skull shape? Well, that's because its jaws and snout were short, unlike other theropods, making its bite weaker, but incredibly quick and chopping. This quick biting action was essential for capturing small prey efficiently, similar to modern crocodiles. The skull and lower jaw of Carnotaurus were highly flexible, allowing different parts of the skull to move when biting to reduce stress on the bones. This flexibility is common in modern snakes and animals that swallow prey whole, hinting that Carnotaurus might have swallowed its prey in large chunks, perhaps supported by evidence of a throat pouch, similar to a pelican. Zooming out of the skull, Carnotaurus had forward-facing eyes, enabling binocular vision for depth perception, a trait seen in many predatory animals. Its very long legs, which made up about 2/3 of its body, along with its muscular tail, were adapted for sprinting and chasing prey, which are again traits shared with other pursuit predators, like subadult Tyrannosaurus. But Carnotaurus does have some distinctive features that really stand out, especially the pair of thick, conical horns above its eyes. These horns are like nothing you'd find on other meat-eating dinosaurs, and they seem to suggest some pretty complex behaviors, maybe combat or showing off. Keep in mind the horns on Carnotaurus are positioned on top of its skull. They are flat on the top, and it's not clear if these horns are sexually dimorphic or if they only appear when the dinosaur is sexually mature. But there are several hypotheses surrounding the purpose of these horns, and one thing's for sure, they weren't used for high-force bashing or ramming between rivals. That's because the structure of Carnotaurus's neck vertebrae and skull couldn't withstand such pressure, making it unlikely for these horns to be used for dominance battles, like bighorn sheep. Similarly, the horns probably weren't employed for stabbing or piercing prey. Their small size and top-of-the-head placement would make it impractical for hunting during a chase. Plus, no other predator in history has used horns in such a manner. But hey, sure made the Carnotaurus look pretty scary though. I mean, come on, you don't want to mess with a big guy that's got horns sticking out of its head. But there's a catch. Despite its tough look, its forelimbs were actually pretty small, with little leftover fingers. This is a common trait among abelisaurids, pointing to an evolutionary change. Now I've got to say, this bad boy had some serious speed on its side, thanks to its remarkable hind limbs. Its legs were long and muscular, with a solid femur and stretched out tibia, the kind of legs you'd expect on a predator that needed to move fast. and with its relatively lightweight body, Carnotaurus could take swift and forceful strides, covering ground in no time. Now, let's talk about that tail. It wasn't just there for show. It played a crucial role in balancing the dinosaur during rapid sprints. The tail had these bony projections, chevrons, and interlocking vertebrae that made it stiff. This stiffness was like a built-in stabilizer, reducing unnecessary side-to-side movements and making forward motion more efficient. But here's the thing, Carnotaurus wasn't just quick. It was the speed champion among large theropods. In fact, studies and fancy biomechanical modeling suggest it could hit speeds ranging from 48 to 56 kilometers per hour, and that's faster than any other big predator of its time, making Carnotaurus the Usain Bolt of the dinosaur world. However, a study of Carnotaurus's skull suggested it could deliver downward thrusting motions against prey. So, the skull might have been used like a club or hatchet, rapidly dropping down while open to penetrate with momentum, aided by the long neck and quick jaw movements. This implies a strategy of swift strikes to take down prey, especially smaller ones. This dino pretty much resembled a cheetah in its pursuit predator strategy. It would sprint after smaller prey, use its head for swift biting or grabbing, and then grip the prey in its backward-facing teeth before swallowing it whole. Now, the one and only Carnotaurus specimen that was unearthed came with a bonus: well-preserved skin impressions. The dinosaur skin was decked out in tiny scales that didn't overlap much, and there were these bigger bumps or osteoderms scattered along its sides. These skin details tell us a lot about how the dinosaur's skin felt and what it might have been used for, like maybe keeping its body temperature just right or offering some protection. Oh, and there's a lot of hype around feathered dinosaurs, but Carnotaurus wasn't really part of that trend. It stuck to the classic theropod look and didn't have any feathers. Carnotaurus females are a little superficial. They might have chosen mates based on appearance rather than combat, pretty boys over tough boys. Since dinosaurs likely saw in color, the horns could have been covered in a range of colors to attract the opposite sex. The strange front-facing angle of Carnotaurus does suggest a unique mating ritual. This might involve females observing males from the front to evaluate them in color and size, similar to the behavior seen in modern birds. While this little bit might seem unusual, dinosaurs in general exhibited unique mating behaviors. It's possible that both display and combat purposes were served by these horns, or there might be an entirely different function yet to be understood. Another interesting possibility is that the horns could have been used to root up soil or strip bark from trees, similar to how male blue wildebeests remove bark to impress females and mark territory. However, without more evidence, the exact purpose of Carnotaurus's horns remains a mystery. However, what's not a mystery is that Carnotaurus was a carnivore. No surprises there. Its teeth were sharp and its body was built for the hunt. But here's where the scientists start to throw around ideas. What size and type of prey did Carnotaurus go for? Some think it went big, like really big, maybe even taking on juvenile and adult sauropods. On the flip side, there's another group suggesting Carnotaurus stuck to smaller snacks, using its agility to catch them. But as discussed earlier, Carnotaurus had a somewhat weak bite compared to its big theropod buddies. So, instead of going in for the kill with a strong bite, it might have gone for a hit-and-run strategy, wearing down its prey over time. Next, let's talk tactics. Carnotaurus obviously wasn't about wrestling matches with its reduced forelimbs. It preferred to use its bite and head as battering rams, and boy was it quick. With its slim hind legs and beefy tail muscles, it was practically a speed demon. Plus, its brain structure hints at a sharp sense of smell, making it a pro at sneaky ambushes. But the craziest thing is, Carnotaurus wasn't too big on using its eyes. Instead, it relied less on sight and focused more on low-frequency sounds to sniff out its next meal from afar. Yeah, you don't want to make any sounds around this guy. Finally, the mystery of how Carnotaurus met its end still confuses many scientists, but the popular belief is that it bit the dust around the same time as other non-flying dinosaurs in South America. It first evolved around 72 million years ago, during the late Cretaceous period. At that time, the world had a fairly warm climate with high sea levels. However, Earth's climate cooled down, and sea levels dropped later in the Cretaceous. And as the climate changed, Carnotaurus went extinct close to 69 million years ago. In the end, Carnotaurus was a hell of a dinosaur with insanely strong legs that made it stand out as the fastest large theropod to ever exist. Meet the T-Rex of the sea, the mighty Mosasaurs. These were fascinating aquatic lizards that lived during the Cretaceous period, spanning from 145.5 million to 66 million years ago. They grew to colossal sizes, and I mean as big as 17 meters. Yeah, that's bigger than 3 SUVs parked together. Think of a swimming Komodo dragon, but like whale-sized. These mosasaurs had a tapered snout, rough skin, and instead of regular limbs, they had 4 fins and their tail looked exactly like a shark's tail, but flipped upside down. What's even more interesting is that these creatures didn't start off as massive. In fact, many scientists think they came from a family of semi-aquatic lizards called the Agilosaurus, which popped up around 99 million years ago in Europe. They were mostly present in the shallow waters of the prehistoric Tethys Ocean, spending most of their time on land, unlike their later descendants. Back then, these early mosasaurs were pretty small, only a few feet or meters long, and they snacked on small fish, lizards, maybe even amphibians, which is honestly a far cry from the epic diets of their later cousins. But over millions of years, they evolved and grew into the legendary rulers of the Cretaceous seas. For millions of years, the Agilosaurus, known as the Agilosauridae, remained unchanged. However, they did face tough competition from 2 dominant forces in the water, the short-necked plesiosaurs and the dolphin-like ichthyosaurs. These 2 groups made the top of the food chain highly competitive, leaving little room for newcomers. Yet, around 90 million years ago, both plesiosaurs and ichthyosaurs went extinct, and that's what created an opening for the Agilosauridae. Now, one thing about these guys is that they were pro at ambush hunting. In fact, these bad boys could go from still to crazy fast in the blink of an eye, kind of like modern crocs when they get that burst of power. You've probably seen how fish bend into a C shape and push off the water to get a fast start. Well, mosasaurs probably did something similar, but on a much bigger scale. They could cover 75% of its body length in just 1 second. So technically, if it was 17 meters away from you, it could get 75% closer in just 1 second. And in the next second, it could pass you and possibly have eaten you for dinner. Also, being hit by a mosasaur would be like getting smacked by a semi-truck. The impact alone could kill prey instantly, not to mention the biting part. These sea monsters could hit 30 miles an hour in just 1 second, making them the ultimate marine predators in history. Mosasaurs, based on their bones, are confirmed as reptiles. However, a significant discovery in South Dakota sheds light on their reproductive habits. A Pleoplatycarpus, often referred to as a mother mosasaur, was found with the remains of several unborn young in her abdomen. This finding strongly suggests that mosasaurs gave birth to live offspring, similar to ichthyosaurs. Unlike other reptiles such as crocodiles, alligators, and turtles, which lay numerous small eggs, mosasaurs likely had a small brood, typically no more than 4 or 5 babies at a time. The mosasaurs were pretty dark in color, and there's a good reason behind that. The predominantly dark body of this massive creature played a crucial role in efficient heat regulation and served as camouflage against intense UV radiation. Researchers discovered this through the study of fossilized skin pigments from an 85-million-year-old mosasaur, highlighting the importance of its unique dark coloration for thriving in the Cretaceous seas. Mosasaurs went through some major changes over time. Their hands and feet turned into flippers, and their tails became powerful tools for swimming. The most significant transformation was their size. They became so huge that it was more likely than not for a new mosasaur to be over 12 feet or 4 meters long. Some even reached massive sizes, like the world record holder, Bruce, a Tyrannosaurus, believed to be 43 feet long. In just 25 million years, these changes allowed mosasaurs to become the top marine predators, which is a surprisingly short time compared to other marine reptiles. They quickly diversified, with 42 members having a strong presence worldwide. But it wasn't just their size that made them successful. Mosasaurs varied widely in size, with the smallest being only 3.3 feet long. This range let them adapt to various environments, including freshwater habitats. There's another pretty cool fact about these huge, powerful marine creatures. Even though mosasaurs lived in water, being reptiles meant they had to come up for air, just like sea turtles do today. They were also non-stop swimmers, always diving for prey and coming up for air, just like us. Yep, they'd pop up to the surface, take a breath, and dive right back in. Scientists tested this in New Jersey and Alabama and found that around 3 to 17% of their vertebrae showed signs of damage from decompression. That's because they'd go up and down repeatedly. Moreover, this badass creature didn't just stick to one type of water. In fact, the first fossils of the mosasaur were discovered in a museum, and they named it after a river flowing through France, Belgium, and the Netherlands. Later, more species were also found in the Midwestern United States, South America, Europe, Asia, Australia, and even Hungary. This just goes to show how versatile this creature was. It wasn't just limited to freshwater, it also made appearances in cold Antarctica, and there are probably a lot more of these guys waiting to be discovered, maybe even near your city. Now, across the mosasaur family, their teeth varied and were highly specialized, with curved teeth that point backward to the throat and an additional set on the roof of the mouth. Any venture into this seagoing lizard's mouth was undoubtedly a one-way trip. The question that follows such a scary bite is, what did the Mosasaurus actually eat? Thanks to a cool find in Canada in 2008, we got some clues. Workers found the bones of a Mosasaurus. The paleontologists uncovered not just the lizard, but also its last meal. They found fish bones in its gut and under its skeleton, belonging to a 3-foot-long fish. What's exciting is that some of the fish bones had bite marks, and their positions hinted that the fish was the Mosasaur's final snack. This is the first time they found such remains inside the Mosasaurus itself. The way the fish bones look suggests a bit of a wild ending. Even though the Mosasaur's head was smaller than the fish, it probably could have swallowed it whole. But the scattered bones tell a different story. The Mosasaur might have caught the fish and tore it into pieces before munching down each part. Another cool feature Mosasaurs had was their jaws. Well, to be fair, it was more handy than cool. They had double-hinged, super flexible jaws that let them swallow prey almost whole, kind of like snakes. There were 2 sets of teeth in their upper jaws. The second set, smaller and positioned farther back, helped them grip onto struggling prey while swallowing it whole. Some mosasaurs even had specially adapted jaws, or rather snouts, like Tyrannosaurus. With all these new evolutionary traits that started from a basic aquatic lizard, these guys became unstoppable. And by the end of the Cretaceous period, their impact was so huge that when a new member entered a new environment, it often led to a complete overhaul in the local fauna. For a good 20 million years, the mosasaurs ruled the seas and oceans, and it seems like they were just getting stronger with time. In their final days, some of the biggest members, like the Mosasaurus, Tylosaurus, and Prognathodon coexisted, making life tough for other ocean dwellers. Interestingly, during this time, they were even more numerous and widespread than the mighty T-Rex. But just when things seemed perfect, their reign came crashing down. It's kind of ironic, really. The same things that helped them to rise to power ended up being their downfall. Remember how extinction events once cleared the way for them? Well, this time they wiped out many mosasaurs, and the survivors couldn't escape its effects. Since then, no mosasaur fossils have been found past the Cretaceous boundary, marking the end of their era. Also, the same big size that made some mosasaurs top predators became a problem. Their massive bodies turned out to be a challenge during the extinction events. Bigger animals struggled more, and none over 55 pounds or 25 kilograms made it through. Sadly, none of the living mosasaurs at the time were even close to that weight. So, their sudden fame ended as suddenly as it began. In the end, mosasaurs were the biggest marine reptiles around, with jaws that nightmares are made of. They truly dominated the sea, and with their incredible speeds, you bet no other creature dared to mess with them. Allosaurus was the most successful predator of the late Jurassic. At 36 feet long, which is about as big as an entire basketball court, this dinosaur wasn't only massive, but it was also one of the fiercest carnivores of its time. And being the top boss among all meat-eating dinosaurs meant this big guy had some serious competition. But with its thin teeth and delicate jaw, how did it manage to become the most successful predator of its time? Allosaurus's hunting tactics were truly out of this world. Stay tuned as we dive into its clever strategies and unique way of life. Allosaurus lived in North America about 155 to 145 million years ago, wandering through open plains and dense forests. It was one of the first dinosaurs scientists really got to know well because it caught everyone's attention. First, it was one of the largest predators around back then, rivaling even the mighty Tyrannosaurus. Its formidable size and powerful jaws put it at the top of the food chain. This meant it had a massive influence on its ecosystem. The body of Allosaurus was like many other animals from the Mesozoic era. Although it was large for a theropod dinosaur in the mid-Jurassic, it lived directly alongside some truly gargantuan sauropods, and they were its main prey. It was a big hunter that walked on two legs, with its body held horizontally. It had a really large head, measuring around 3 feet in length. That's like the size of a grown penguin. And of course, inside it was a huge skull. It had a short but thick neck, a long tail to balance its massive body, and relatively small arms sticking out from its torso. The biggest Allosaurus we know of was about 9.2 meters long, from its nose to its tail, which is pretty large for a dinosaur from the Jurassic period, but it's smaller compared to later dinosaurs like Tyrannosaurus. On average, the most studied species, Allosaurus fragilis, was about 8.5 meters long, which is about the size of a London bus. But even though it wasn't the biggest dinosaur around, with a weight of nearly 2 metric tons, it was still well equipped to hunt large, plant-eating dinosaurs. The skull of Allosaurus is one of the most unique features among theropods, especially those from the Jurassic era. It was long and deep with sharp, backward-facing teeth that were perfect for catching big prey. Its jaws were also powerful, which tells you it could apply a lot of pressure when catching its prey. There was also a bony horn-like structure above its eyes. These horns might have formed a crest when the dinosaur was alive, possibly brightly colored. This could have helped Allosaurus communicate and attract mates, or signal to others of its kind. Now, this dinosaur had a pretty large torso, but it had relatively fragile bones supporting it. Surprisingly, these bones were still strong enough to protect its internal organs while allowing it to move easily. These bones also helped keep its overall weight down. Like many big theropods, Allosaurus had small front limbs compared to its long, strong back legs. Each hand had 3 fingers, each tipped with sharp, curved claws meant for cutting into the flesh of its prey. Even though its arms were small, they were still powerful and effective for hunting. It also had long back legs, and hey, they were strong, although their claws weren't as sharp as those of other theropods from the same time period. At the end of Allosaurus's body was a long, tapering tail, typically measuring between 4 and 5 meters in length. This tail served as a counterbalance when the dinosaur was moving, whether walking or running. It helped keep the dinosaur balanced, preventing it from being too top-heavy, and thus ensuring its success in hunting. Speaking of its hunting success, are you wondering what this big guy liked to chew on? Well, Allosaurus was the most successful predator of the late Jurassic, and our paleontology department seems to agree that it actively hunted large animals. In fact, there's strong evidence of it attacking Stegosaurus. We found an Allosaurus tail vertebrae with a wound from a Stegosaurus tail spike, and a Stegosaurus neck plate with a wound that matches an Allosaurus snout. But sauropods were probably on Allosaurus's menu too, either as prey or scavenging targets. We've seen marks on sauropod bones that match Allosaurus teeth, but given how huge sauropods were, Allosaurus might not have been able to take down fully grown sauropods unless it hunted in groups. Its skull was relatively small, its teeth weren't huge, and it had a bite force similar to that of a leopard. Sauropods, on the other hand, were massive. Maybe Allosaurus preferred hunting younger sauropods instead of adults. It's even been compared to saber-toothed mammals from later eras. A lot of similar features like weaker jaw muscles but stronger neck muscles and the ability to open its jaws really wide have been found. Even though Allosaurus didn't have saber teeth, it was thought that it might have used its jaw and neck muscles to deliver powerful slashing attacks that would have weakened its prey over time. A recent study using computer models looked into how Allosaurus actually hunted, and it turns out, despite its scary teeth, its bite wasn't super strong. But despite being small, its skull was really tough, like a fortress. So, instead of crushing bones, it probably used a slash and slice method. This means it used its strong neck and skull to drive its teeth into prey and tear off chunks of meat. This research helps us understand how Allosaurus survived, or should we say thrived, as a hunter millions of years ago. But what was its habitat like? And which other animals did it coexist with? Well, Allosaurus was a dominant predator in the Morrison Formation, and it makes up around 70 to 75% of large carnivore fossils found there. This formation was a semi-arid environment with seasonal changes, featuring flat floodplains and varying vegetation, from forests to savannas. The area was rich in fossils, including diverse plant and animal species. Besides Allosaurus, other dinosaurs like Apatosaurus, Camarasaurus, Diplodocus, and Stegosaurus also lived there. Allosaurus shared its habitat with fellow predators like Ceratosaurus and Torvosaurus, each likely occupying different ecological niches. Ceratosaurus and Torvosaurus may have preferred wetter areas, while Allosaurus was adapted to drier floodplains. Evidence suggests that Allosaurus was both a predator and sometimes even prey. Scavenging behavior is indicated by bite marks found on Allosaurus's bones, likely from other carnivores like Ceratosaurus or Torvosaurus. Similarly, Allosaurus was found to scavenge on its own species, as shown by bite marks on Allosaurus bones. The many bite marks might mean they relied more on scavenging when food was scarce, or maybe they just really couldn't stand each other. We'll talk about the real reason behind this behavior later in the video. Now, what was their skin like? Well, fossil evidence tells us that these guys came with real scaly reptilian skin. In one case, a young Allosaurus had small scales, around 1 to 3 millimeters wide. Another set, possibly from the tail base, had larger scales, some reaching up to 2 centimeters wide. But what about their brains? We mentioned earlier that they had big heads. So did this beast have a mega brain as well? Well, based on scans of its brain structure, Allosaurus had a brain more similar to crocodiles than birds, which are also archosaurs like dinosaurs. Its inner ear structure suggests its skull was held nearly horizontal, not tipped strongly up or down. This also means it was better at hearing low-frequency sounds and might have struggled with subtle noises. Its sense of smell was probably sharp, with large olfactory bulbs for detecting scents. But this was pretty standard for dinosaurs its size. So were these features enough for it to exist as a solitary predator, or did it live in groups? Since the 1970s, people have thought Allosaurus hunted in groups, especially to take down big dinosaurs like sauropods. Some even think they brought food back to their young. But there's not a lot of proof for this. In fact, there's more evidence that Allosaurus mostly fought each other, rather than working together. There are signs of fights between these guys, like bite marks on skulls and injuries to their belly bones. Some researchers think that when you see a bunch of Allosaurus fossils together, it's not because they hunted together, but because they were drawn to a spot where there was already food, maybe like a dead or injured Allosaurus. This could also explain why there are a lot of young Allosaurus fossils found together, as younger ones might have been more likely to get hurt in these situations. There's even evidence that this dinosaur might have sometimes eaten others of its kind. This is due to the fact that some of their teeth have been discovered mixed in with their bones. So, while it's possible Allosaurus hunted in groups sometimes, it's kinda more probable they were more interested in their own meals than working together. Now let's roll the clock back to when this dinosaur was first discovered. The story of how Allosaurus was discovered and studied is a bit tangled due to a lot of names being thrown around. This happened during what's known as the Bone Wars in the late 1800s. It all started when a bone was found in Colorado by Ferdinand van der Veer Hayden in 1869. People thought it was just a petrified horse hoof. Hayden sent it to Joseph Leidy, who first thought it belonged to a European dinosaur, but later decided it needed its own name, Antrodemus. The name Allosaurus came from a small collection of bones found later, including bits of vertebrae, a rib, a tooth, and part of an arm bone. These were named Allosaurus fragilis in 1877 by Othniel Charles Marsh. The name means strange lizard because its bones were different from other dinosaurs known at the time. Fragilis means fragile because of some light features in the bones. Now, if you're wondering where one might find one of these fossils, the Morrison Formation is a layer of rock dating back to the late Jurassic period, about 155 to 148 million years ago. It covers much of the western United States and holds many dinosaur fossils, including Apatosaurus, Stegosaurus, and Allosaurus. The formation's river channels hold the most dinosaur bones. Notably, two almost complete Allosaurus skeletons known as Big Al and Big Al2 were discovered there. And at Dinosaur National Monument, the Wall of Bones remains preserved to show the huge amounts of fossils found in the Morrison Formation. As for this dinosaur's family tree, Allosaurus was part of a group called Allosauridae, which includes big meat-eating dinosaurs in the Carnosauria group. The name Allosauridae was made up by a scientist named Othniel Charles Marsh in 1878, but it wasn't commonly used until the 1970s. Before that, people often used Megalosauridae for big meat-eating dinosaurs, including Allosaurus. This caused some confusion, especially since Antrodemus was sometimes used instead of Allosaurus around the same time. It's important to remember this when looking at old books and articles written before James Madsen's study in 1976. After Madsen's study, Allosauridae became the preferred term, although it wasn't very well defined. People often used it for various big meat-eating dinosaurs, especially those larger and more famous than megalosaurids. Some other dinosaurs thought to be related to Allosaurus included Indosaurus, Compsognathus, and Stegosaurus. But with more recent research, we've learned that none of these dinosaurs are actually allosaurids. Now, why did this amazing, powerful beast die out? The truth is, Allosaurus probably died out around 144 million years ago. We're not exactly sure why, but there are some ideas. One is that there was a really bad drought back then, which led to lots of dinosaurs, including Allosaurus, dying off. This theory gets support from finding big fossils in Utah, but there's also a new idea based on a fossil called Big Al2, which had some health problems. Maybe diseases were spreading, and some pathological infections played a role in the species' decline. In the end, it's clear that Allosaurus ruled as one of the top predators of the late Jurassic. It made use of clever hunting strategies to become one of the most successful carnivores of its time. With its unique skull and powerful jaws, it could take down large prey with ease. You bet, no small dino wanted to get in this guy's way when it left home. And that's a wrap. If you could bring back Allosaurus and pit it against another dinosaur, would you choose the Tyrannosaurus Rex or the armored Ankylosaurus? Drop your thoughts in the comments below. Few people know much about the roofed lizard of the late Jurassic, Stegosaurus, at least beyond the fact that A, it had triangular plates on its back, B, it was dumber than the average dinosaur, and C, plastic Stegosaurus figurines look pretty cool on an office desk. But this 150 million-year-old dinosaur has a lot more to show for itself. For one, the Stegosaurus was about as old to T-Rex as T-Rex is to us. That really makes it a whole other ancient beast, and perhaps the most iconic member of the Stegosaurids. During the end of the Jurassic period, about 145 to 200 million years ago, the mighty Stegosaurus roamed the Earth in places like western North America. These creatures were part of a group called stegosaurs, known for their four-legged stance and long, beak-shaped heads. But inside the gigantic beak-shaped head of Stegosaurus was a walnut-sized brain, and that's what makes scientists think it was a bit of a bimbo. But you'll be surprised to know that it's plausible the Stegosaurus also had another brain, located in its butt, to make up for that small brain size. A dinosaur with two brains? Could it really be? Before we let you in on that, here's what the dinosaur was really like. Stegosaurus was a type of dinosaur known for its large body, spiked tail, and plated back. There were three known species: Stegosaurus stenops, Stegosaurus ungulatus, and Stegosaurus sulcatus. It had 4 sturdy legs and a tail adorned with plates and spikes, measuring 60 to 90 centimeters long. With a length of 9 meters from head to tail and a height of 4 meters, it was built like a bus. During the late Jurassic period, it coexisted with massive dinosaurs like Diplodocus and formidable predators like Allosaurus. Weighing up to 7 metric tons, it was comparable in mass to a large elephant. But despite their size, they were relatively slow-moving creatures capable of reaching speeds up to 5 miles per hour, 7 kilometers per hour at their maximum. That's half of how fast an average human can run. Paleontologists believe Stegosaurus mainly ate low-lying plants like cycads, and a computer simulation from 2016 showed that its bite force was similar to that of a sheep or cow. Their distinctive backplates are what they're most famous for, but Stegosaurus had other interesting skeletal traits too. It had a long, arched spine and noticeably shorter front limbs compared to its hind limbs. This likely resulted in the dinosaur holding its tail high in the air while keeping its head low to the ground, which would have been convenient for feeding on shrubs at ground level. It also had a distinct spinal structure with 10 neck vertebrae, 17 back vertebrae, 27 tail vertebrae near the sacrum, and a total of 46 tail vertebrae. These bones were mostly similar in shape, only varying in size, with the largest ones around the back and base of the tail. Looking at its limbs, the well-preserved skeletons show that its front limbs were shorter and thinner compared to its longer, wider hind limbs. This difference in size led to its unique posture, where its hind limbs lifted its tail high while its head and neck were lower, making it easier for grazing and using its tail for defense. The hind feet of Stegosaurus had 3 toes, while the front feet had 5, with the innermost toe forming a hoof-like structure on each foot. Now for Stegosaurus's most unique features: the plates and tail spikes. It typically had between 17 and 22 plates, arranged in 2 rows along its spinal column. These plates were kite-shaped, with the largest ones over the hips reaching over 60 centimeters wide by 60 centimeters tall in extreme cases. But contrary to what you might expect, the plates were not entirely made of bone, nor were they directly attached to the skeleton. Instead, they were modified scales known as osteoderms that projected upward from the skin on the dinosaur's back. These plates had bony cores that toughened them and kept them upright throughout the dinosaur's life. On top of this, there may have been a tough sheath of keratin covering them. Many modern animals have osteoderms, similar to the tough bony structures on the back of crocodiles or alligators. Like these modern examples, Stegosaurus's plates served a protective function. But apart from that, the patterns on the plates on each Stegosaurus species might have been crucial for identifying different species. It's believed that each species had unique plate arrangements. For instance, Stegosaurus stenops had plates arranged alternatively down its spine, while other species may have had plates in neat rows, similar to the patterns of a zebra. No 2 plates on any individual Stegosaurus were the same size or shape. The function of these plates has been a topic of debate among paleontologists. Some suggest they were for defense, forming an armored layer to protect the dinosaur from attackers. However, this theory is now considered outdated due to the fragility and placement of the plates. Some still hold on to this idea, but it's not widely accepted. Another theory, proposed in 1986, suggested that the plates of Stegosaurus were actually cores of horns along its back, similar to those seen in some mammals today, serving as protection from attacks. Perhaps Stegosaurus could orientate these plates to aim the horns at attackers, but this theory hasn't gained widespread support. Now, the theory that has become widely accepted about the function of Stegosaurus's plates is that they were used for thermoregulation. They helped cool the dinosaur when it was warm and absorbed sunlight to warm it up when it was cold. This idea is supported by evidence of blood vessel networks within the plates, suggesting they could absorb heat or cold from the environment and transfer it through the dinosaur's body. Similar structures are found in modern animals like elephants and alligators, indicating that this function is quite plausible for Stegosaurus plates. Moving to its skull, these guys had a thin, elongated skull that was relatively small compared to its massive body. It was positioned low on its body, making it difficult for the dinosaur to move its neck up and down. Scientists believe Stegosaurus was a browser, not a grazer, meaning it fed on plant matter from shrubs and ferns close to the ground. Its snout had a toothless, beak-like structure similar to some modern birds and turtles, which it used to shred vegetation for consumption. Dinosaurs, kinda like Winnie the Pooh, are often portrayed as dumb creatures. They're said to have small brains, similar to modern reptiles, and among them, herbivores like the large sauropod Stegosaurus typically have even lower brain-to-body ratios. In fact, Stegosaurus is often said to have had a brain the size of a walnut, although it was more like the size of a lime or a dog's brain. Still, considering its massive size, it had a relatively small brain, weighing no more than 80 grams, which is about 0.001% of its total body weight. That makes it one of the least intelligent dinosaurs compared to its body size. Now, absurd as it may sound, there's a rumor that Stegosaurus had a second brain located in its hips. This idea started back in 1881 when a scientist mentioned an enlarged cavity above the dinosaur's hip region, calling it a posterior brain case. However, there's no evidence to support this theory. Some researchers think this cavity might have stored glycogen, a type of sugar that provides energy to cells. But even without a second brain, Stegosaurus has some cool claims to fame. It's the official state fossil of Colorado and even inspired parts of Godzilla's design. Now, Stegosaurus may have been large, but it lived alongside even larger dinosaurs in the late Jurassic period. Sauropods like Camarasaurus reaching 60 feet, 18 meters in length, and Diplodocus measuring up to 80 feet, 24 meters, overshadowed Stegosaurus. And although it didn't have to contend with Tyrannosaurus Rex, it faced other formidable predators in its ecosystem. Allosaurus, for example, was a common threat, reaching lengths of up to 28 feet, 8.5 meters, with powerful jaws and serrated teeth. However, Stegosaurus wasn't defenseless as it had 4 tail spikes that it could use for protection. Fossil evidence suggests that these spikes were indeed used in combat, with about 10% of examined specimens showing signs of trauma. One example includes a deep wound on an Allosaurus pubic bone, likely caused by a Stegosaurus tail spike. It seems that these dinosaurs engaged in battles, resulting in injuries on both sides. For instance, a Stegosaurus neck plate with signs of gnawing from an Allosaurus was found in Cleveland Lloyd Dinosaur Quarry in Utah. But Stegosaurus was well equipped to deal with such attacks, as the underside of its throat was covered in tiny, pebble-shaped chunks of bone. Called gular armor, it helped protect the dinosaur when Allosaurus and other carnivores went for the jugular. Stegosaurus, like many plant-eating dinosaurs of its time, swallowed small rocks called gastroliths to help grind up tough plants in its large stomach. Given its massive size, it likely had to consume hundreds of pounds of ferns and cycads daily to sustain its metabolism, which was presumed to be cold-blooded. But it's also possible that Stegosaurus swallowed rocks because it had a brain the size of a walnut. Who knows? Besides this, these dinosaurs were among the first ever to evolve cheeks. Despite lacking in other areas, this dinosaur had a relatively advanced anatomical feature. Experts suggest that Stegosaurus may have had primitive cheeks based on the shape and arrangement of its teeth. Now, cheeks were important because they enabled Stegosaurus to thoroughly chew and pre-digest its food before swallowing. This allowed it to consume more vegetation compared to dinosaurs without cheeks. Stegosaurus was closely related to Ankylosaurus, both belonging to the group of thyreophorans or shield-bearers. While Stegosaurus lived during the late Jurassic period, Ankylosaurus thrived millions of years later during the Middle to Late Cretaceous period. Both of these dinosaur families were 4-footed plant eaters, with Ankylosaurus being characterized by its heavy armor. This armored protection likely made Ankylosaurus even less appealing to predators like raptors and Tyrannosaurus compared to Stegosaurus. The first stegosaur ever found was Dacentrurus, discovered in Swindon, UK, in 1874 by Richard Owen, the scientist who coined the term dinosaur. Then, in 1877, Othniel Charles Marsh found Stegosaurus armatus in the Rocky Mountains, USA, which gave the group their name. Initially, it was thought that the plates laid flat along the back for protection, but later discoveries showed that they stood upright. However, there's been a lot of confusion with these dinosaurs. Many fossils originally thought to be different Stegosaurus species are now considered the same species, or even from a different genus. Even Stegosaurus armatus has been replaced as the main representative of its genus by Stegosaurus stenops because of identification concerns. All of this shows how tricky it's been for paleontologists to understand the family tree of these dinosaurs. Fossils of Stegosaurus are rare, and they often consist of only a few bones, making it hard to compare species accurately. However, a new stegosaur species, Bashosaurus primitivus, has been discovered in China, dating back to the Middle Jurassic period. This finding suggests that stegosaurs may have originated in Asia, specifically within the supercontinent of Laurasia over 165 million years ago. Bashosaurus primitivus could be a close relative to the ancestor of all stegosaurs. This discovery sheds light on the early evolution of these dinosaurs and their spread across different regions of the world. However, they eventually disappeared by the late Cretaceous period. But why? Well, Stegosaurus faced extinction due to a combination of factors. Firstly, a decline in their primary food sources, such as cycads, cycadophytes, and bonnetontails, may have contributed to their demise. These plants were essential for Stegosaur's diet, and their disappearance could have led to a shortage of food. Additionally, Stegosaurs faced stiff competition from other dinosaur groups, including ankylosaurs, ornithopods, and macronarian sauropods. Macronarians, with their less specialized feeding habits and stronger necks, may have outcompeted stegosaurs for resources. And lastly, the emergence of new herbivorous dinosaurs, like iguanodonts, posed a challenge to stegosaurs. Iguanodonts were efficient at processing plant material thanks to their ability to chew food using cheeks and multiple teeth. This allowed them to consume food more quickly and efficiently than stegosaurs. In the end, Stegosaurus remains an iconic figure in the world of dinosaurs. Its distinctive bony plates, spiked tail, and huge, imposing structure has inspired beasts like Godzilla. And hey, even with its relatively small brain, it was still a formidable presence in the late Jurassic period. And that's a wrap. Do you believe that Stegosaurus actually had 2 brains, or just 1? Drop your thoughts in the comments below. And if you enjoy learning about ancient creatures, make sure to hit that subscribe button and stay tuned for more cool stuff about the past.